Good afternoon, welcome back. So our next presenter for this session is Gustavo.R.Silva. So they're a Linux kernel engineer, and today they're going to be talking about enhancing spatial safety in the Linux kernel. So please make them feel welcome.
Yeah, hello everyone. Thanks for coming to my talk. Well, my name is Gustavo.R.Silva. I am an upstream Linux kernel engineer. And well, today we are going to be talking about Linux kernel hardening in general, but in particular about how it is that we need to fix thousands of these certain types of warnings. We are going to see what they are and how it is that we came to be in this position. My work in the kernel community has always been supported by the Linux Foundation, and in recent years also by Wfamnae. So thanks to those organizations for allowing me to be here. And also thanks to the organizers of the conference for this opportunity. Okay, so a little bit about me. I've been doing upstream Linux kernel hardening for the last 9 years. I've been working on proactive security, and I am a team member of the Kernel Self-Protection Project, which is basically the Linux kernel division of the open source security team. However, I am not a Google employee. Okay, this is the agenda for today. We're going to start with something very basic. We are going to explain what it is a flexible array member, how we use a flexible array member in the kernel. Then we are going to see what is this compiler option about. And of course, we are going to talk about a little bit of the history behind how we got ourselves into this problem, because well, now we have to fix thousands of these warnings. And of course, at the end, I'm going to share a little bit about what is coming in the kernel hardening project, and of course, some conclusions at the end. Okay, let's start with this. Well, first, before I even begin, how many kernel engineers are in the audience? If you can help me. Okay, awesome. How many of you work exclusively upstream? Okay, a couple. Okay, few. Great. Okay, and the rest, I suppose, well, you are familiar with the C language. If not, don't worry. It's fairly simple. Okay, so. A flexible array member is merely an array that we declare at the end of a structure. And as you can see, the syntax is with empty brackets. One of the requirements for to use a flexible array member is that it should be the last member of the containing structure. So for the purpose of this presentation, we are going to say that a structure that contains a flexible array member is a flexible structure. So I'm going to be referring to a flexible structure throughout the whole presentation. So it is important that we are on the same page. It's important to pay attention to this, because if we don't place the flexible array member at the end of a structure, and let's say we place it somewhere in the middle, the compiler is going to emit an error. So our code is not going to compile, right? So this is considered a hard error for the compiler. So this means that we don't necessarily have to use a special compiler flag or option to detect these sorts of issues. The reason why we cannot place a flexible array member in the middle of a structure is because when we use this flexible array member at runtime, we are going to allocate certain heap space for this array. So the moment we access this heap space, or we write something into the flexible array member, we are going to overwrite the following adjacent members in the structure, right? So that's undefined behavior. So that is the reason why this is not possible. Okay, another important characteristic of a flexible structure is that when we need to implement one of these code constructs, it is useful to include a counter member. In this case, in this example, count is that counter member. So this member, we are going to use this member to store the total number of items or elements our flexible array member is going to contain at some point at runtime. So this is useful information to have. Another important thing to mention is that the C standard says that a flexible structure, this is again a structure that contains a flexible array member, cannot be or may not be a member of another structure. So this is part of the standard. However, in the kernel, well, we have our own opinions, and well, we are going to see how it is that we are not following this advice from the standard, and that is actually why we are getting into a lot of trouble. But that's how we need to use these flexible structures. Lastly, in Clang 18, which is the last release, the last version of Clang, a new attribute was released, the counted by attribute. This attribute is actually coming in GCC 15. It's under development in GCC. Why this attribute is important is because now we have a way to link our counter member to our flexible array member. So with the help of this attribute, now the compiler is going to instrument our code so that at runtime we can have runtime bounce checking coverage, right? And well, the last year I wrote a blog post about this, how to use the counted by attribute in any C code base, particularly in the Linux kernel. I included a link so you can check it out. I'm going to be saying a couple of words more about counted by in the next slides. So let's continue. Okay, well, this compiler option, this Wflex-array-member-not-at-end compiler option, it's a fairly long name, right? Well, it was developed by Xin Zhao a couple of years ago. Xin is a GCC developer. She's part of the Kernel Self-Protection Project. She's basically the person on the GCC side that's been developing all the compiler options and attributes we have been using in the Kernel Self-Protection Project to enhance the security of the kernel over the last years. So she's a great developer. Okay, so what is this? What this compiler option complains about? We have at the top a flexible structure, and at the bottom we have a composite structure that contains a member of the type of our flexible structure, right? We have the object middle is that member. Okay, this is a warning for when we enable this compiler option. The compiler is going to report a warning in this case, because well, we cannot have flexible array members. We cannot end up having flexible array members in the middle of composite structures, right? So this is what this compiler option is about. And in the case that we have a member of the type of the flexible structure at the end of the composite structure, that's perfectly fine, because that means that our flexible array member is going to be at the end. So that is fine. However, if we have a member of the type of the composite structure in the middle of another structure, now we again have a warning, because at the end we are going to have a flexible array member in the middle of any number of nested structures, right? So, and so on. So this is a problem. Okay, so what is wrong with flexible array members in the middle? Well, first, let me remind you that the C standard says that we cannot have a flexible structure as a member of another structure. However, we can do that. We've been doing that, well, since forever. But this is an extension, right? And as an extension, we can have a flexible structure either as the last member of a composite structure or not the last member. In this case, this last part is deprecated. This is what we want to get rid of. And well, we have thousands of these instances in the Linux kernel, and it's becoming a big issue. One of the reasons why compiler people don't want us to get rid of these instances of code is because when they try to calculate the sizes of composite structures, they get into trouble, because it's like having a hole in the middle of another structure, because we never know how big this array is going to be until we run the code, and well, we compute its size at runtime, right? But at build time, we have not access to that information. Another reason, now from the kernel side, another reason we want to get rid of these instances is because, as we were seeing, that one of the requirements for to use a flexible array member is that it should be the last member of a flexible structure, because otherwise we are going to corrupt any following members, any adjacent following members, well, it is the same case, right? It doesn't really make sense that we cannot use flexible array members in the middle of a flexible structure because that's a hard error and that's undefined behavior. And now, all of a sudden, when it comes to composite structures, we can place flexible arrays in the middle, and that doesn't make sense really. And actually, this is exactly the same problem we want to avoid when we don't place flexible array members in the middle of flexible structures. So in this case, what the compiler is, instead of emitting an error, the compiler is warning about this issue because it's inviting us to change our code, right? However, we've been coding like this for ages, so any C code base out there, I'm pretty sure that is polluted with these kinds of issues. And actually, I found real bugs thanks to this compiler option, and those bugs, of course, are already fixed in mainline. So yeah, it is a really useful compiler option, and it is a problem that we need to fix in the upstream Linux kernel. Okay, so now we have to fix thousands of these warnings. So before we get into the details of these warnings, let's go a little bit through the history of how it is that we ended up with these thousands of warnings in the kernel. So back in 2019, we started the effort of transforming one-element arrays and zero-length arrays into flexible array members. So basically, before C99, the only option that people had to implement a flexible array was either using a one-element array or a zero-length array. So before C99, we didn't have proper flexible array members, so that was the option that people had at the time. However, this has proven to be buggy, and we have fixed a lot of issues in the process of transforming these one-element arrays and zero-length arrays into flexible array members. So at the time, we decided to call one-element arrays and zero-length arrays that were being used as flexible array members fake flexible arrays. So that's how we call it at the time. And well, of course, now this is how a flexible structure should look like, and this is how a proper flexible array member should be declared. So this started actually when I ran into this issue. This was back in 2019. I was doing other hardening stuff, and by mere chance, really, I ran into this problem. And it caught my attention because what we have here is a zero-length array. Again, I'm sorry, this is new, so I'm getting used to it. Okay, so what we have here is a zero-length array in the middle of a structure, and this commit introduced a new member, right, after the zero-length array. So the problem here was that this zero-length array was being used as a flexible array member at runtime. This is some heap memory, some heap space was being allocated, and then RCU head was being corrupted. The reason why the compiler couldn't detect this is because it wasn't a C99 flexible array member. If it were a C99 flexible array member, the compiler could have detected this issue, and of course, well, I mean, this would be a different story. So the fix for that is simple. We just transform the zero-length array into a proper C99 flexible array member, and we place it at the end of the structure. And with this, now if someone else comes and make the same mistake, the compiler is going to complain. So yeah, this kind of issue cannot enter the code base anymore. And well, yeah, I discovered this bug in 2019. However, the issue was introduced in 2011. So we had this problem for 8 years in the kernel without detecting it. Okay, so let's continue with the story. Then this new compiler option, strict flex array, was implemented in Clang and in GCC. Thanks to this compiler option, now only C99 flexible array members are considered flexible arrays or variable length objects in the Linux kernel. So in Linux 6.5, C99 flexible array members became first-class citizens in the Linux kernel. So now if you want to implement a flexible structure and you are very used to using one-element arrays or zero-length arrays, the compilers are going to assume that that is not a flexible array member. So the size of that array is either the size of that one element or size 0 in the case of zero-length arrays, right? So you are not going to be able to use one-element arrays or zero-length arrays as flexible array members, as it used to be. Then, well, in recent times, the counted by attribute was implemented. This was released in Clang 18 and is currently under development in GCC. It's about to be released in the coming version of GCC. And well, again, this counted by attribute is useful because now we have a way to tell the compiler where it should go and look for the number of elements, and with that information, calculate the size of flexible array members at runtime. So yeah, we are gaining bounds checking. Now, on the side of the kernel, what we have been doing is we've been looking for all those flexible structures that contain a counter member, and we have been annotating its flexible array with the counted by attribute. It's not that simple, really. I mean, there are a lot of nuances around these annotations. In the blog post I wrote, I share a lot of kernel code, and I explain those nuances, and I explain exactly how to use the counted by attribute and the things you gotta pay attention to, so you don't trip yourself in the process. And well, ideally, if you want to use a new or you need to implement a new flexible structure, ideally you are going to use the counted by attribute. Okay. So now, fixing thousands of these warnings. I was curious about how many of these warnings we had before 2019, and it turns out that we have only 8,000 of these warnings, right? This is before I even ran into this undefined behavior problem in 2019, and of course now we have more than 60,000 of these warnings. So it's a lot. So this only tells us that we have gained absolute visibility into the issue we have had in the kernel for years now. So, well, fortunately, about 650 of those 60,000 warnings are unique issues. However, we are still hundreds of issues to fix, so it's still a problem. So when I was facing this problem, I was really feeling very overwhelmed because I was first thinking about this problem in terms of, okay, I gotta need to look into each one of these issues and try to refactor the code and move around the code so that the flexible array member always ends at the end of the flexible structure, or of the composite structure, rather. However, that would imply that probably I would have to become like an expert on every subsystem and on every driver in the Linux kernel. Well, I mean, I don't have time for that. And well, I was reading these issues, and fortunately, some patterns started to emerge. So in the next slides, I'm going to share with you at least 4 different categories of these issues and how it is that I am addressing them. Okay, so the first category is when the flexible array member is not being used at all. So here, this is kernel code. We have our flexible array member, and of course, well, we have our warning here. And what happened with this code is that while reviewing the kernel, I realized that no heap space was being allocated in any place for this flexible array member. So probably what happened here is that at some point when this code was introduced, it was being used. However, as the code evolved, probably well, they stopped using this array, or probably it was never used. So here the solution is fairly simple. All I have to do is just remove that flexible array, right? We don't need it. It's not used. So we can remove it. And with that, well, I guess with this commit, I fixed like 100 of those warnings. And yeah, that was great. Okay, the second category I found is when the flexible array member is never accessed through the composite structure. We can allocate heap space for the flexible structure and the flexible array member. However, when it comes to a composite structure, we actually never use the flexible array member. We might use the headers, we might use the header part of the struct flex of the flexible structure. In this case, that would be member A, B, or even count, right? But as in the case at the bottom. However, we never do something like this. We never the reference a pointer to the composite structure, and through the middle member use the flexible array member. That never happens. So that means that we just need to find a way to remove the flexible array member, or to prevent the composite structure from seeing the flexible array member. Okay, so what can we do in this situation? Well, one of the things that we could do is probably, if we know that the only member that is not being used in the problematic member is the flexible array member, well, we probably could create a couple of structures, or rather, we could create a new structure that in this case we are going to call flex header, just to illustrate that it's going to be the header part of the flexible structure. So if you notice, this structure is fairly identical, with the exception that we don't include the flexible array member, right? So two separate structures, of course, the original flexible structure and the header part of the flexible structure. Okay, so then the next thing that we can do is, well, identify the conflicting member, in this case middle, and we just change the type of middle from struct flex to struct flex header. So with this, the warning goes away, and the life is beautiful, right? Because composite structure has no visibility into the flexible array member anymore, so the compiler is totally fine with that. Okay, but what is the problem with this approach? Well, one of the problems is that we duplicate code, right? And that's unnecessary, really. We have basically two identical structures, so maintainers would have to, if you need to change something in the flexible structure, you also need to pay attention and modify the newly created structure, in this case, struct flex header. So yeah, I mean, that is not the ideal solution. Instead of that, what we are using in the kernel is we are using the struct group helper. How many of you are familiar with the struct group family of helpers? Do you know about it? A couple of people? Awesome, great. Okay, don't worry. I mean, we are going to see how to use this helper. It's a very versatile helper. It's really useful. Okay, let's see how we can fix this issue with using this helper. Okay, internally, what struct group tag does is that it creates a new struct type, and well, through that struct type, well, that is a new type. Now we can use that new type to replace struct flex, the struct flex type. So now struct group creates a new struct type. With that, we left the flexible array member out of the equation. The compiler is no longer able to see that flexible array member when we use the new type for the middle object. And well, the magic of this, of struct group is this. Well, this was created by Keith Cook, which is the leader of the Kernel Self-Protection Project, and also by Keith Packard. And well, internally, this is how struct group looks like. We have a union, right? And we have an anonymous structure. So thanks to that anonymous structure, we can continue to access the members in the flexible structure without necessarily have to go through a substructure identifier, right? And then we create a new type with the header part of the flexible structure. So basically, we group all the members in the flexible structure with the exception of the flexible array member in a new type, and we use that new type to replace the type of the conflicting member in the composite structure. And well, I mean, there is a whole story behind how this helper was created. This is not the main reason why this helper was created. There's a whole story. I have previously talked about this. If you are curious about the origins of this helper, I have included some resources at the end of the presentation. So when you have access to the slides, you can take a look at it, and you are going to see a couple of presentations where I actually go deep into the story. It's an interesting story, so you gotta check it out. Okay, so let's go back to our code. So yeah, so this is how we are fixing these sort of issues. In this case, we create a new struct type with this identifier, and we just replace the type of the conflicting object, and we don't need to create a completely separate structure, right? We can do that thanks to the magic of struct group tagged. And well, here, just as an example, these two pieces of code are identical, so we can still accessing the members in this group directly without necessarily having to go through the identifier that we created here, right? So these two blocks of code are equivalent. And well, this is kernel code, and this is an example of how I fix some of these issues using struct group. And in this case, I am using a double underscore struct group because if you notice, this flexible structure is packed. So with this other helper, we can include attributes. We can group struct members with attributes. So otherwise we would change the alignment of the structure, and we would get into trouble. And well, this is the second part of the commit. Here I'm just replacing. This is the conflicting object, and I'm just replacing the type of the flexible structure with the type of the structure that doesn't contain the flexible array member, right? Which is this one. And that would be the fix. Okay, so case 3 is the most complicated. So here, well, okay, let's see how. Let me try to explain this. It's a bit complex, but let's see. What's going on in case 3, what I discovered is that we have sometimes implicit unions between a flexible array member and a fixed size array, which the type of the fixed size array is going to be the same type of the flexible array member, right? So in this case, struct foo is the type of our flexible array member. Then we have our conflicting member, which is this one, flex in the middle. But immediately following after this member, we have a fixed size array of the same type of the flexible array. Okay, this tells me that that people knew what they were doing when they were implementing this, because they knew upfront how large or how big the flexible array member, or rather how many bytes of memory the flexible array member would need at runtime. So they just what they do, well, upfront they declare a fixed size array just after the flexible structure, and well, now at runtime you can iterate over your flexible array member up to the size of the fixed size array, and that's a hack, but it still has its problems. Okay, so yeah, with an implicit union between a flexible array member and a fixed size array, now in the best scenario, the flexible array and the fixed size array, they are going to share the same address in memory, right? And the reason I say that in the best scenario is because I have run into a couple of cases where I discovered a hole between the flexible array and the fixed size array. And probably at the beginning, probably that was correct, that code was correct. But again, as the Linux kernel is evolving all the time, probably one member in the composite structure was removed or was added, so that changed the alignment of the composite structure, so that modified the offsets of the objects, and that causes problem, right? Okay, so this is kernel code. This is an instance that I ran into a while ago. Okay, so what we have here is, this is our conflicting object. This is the flexible structure. Of course, I use through group to isolate the members in the flexible structure and leave out of the equation, leave the flexible array member out of the equation. And then I changed, of course, the type of the conflicting object. And again, just with this, the compiler loses visibility into the flexible array member. And up to this point, the compiler, the warning would be gone, right? However, this is just the first part of the commit. And well, we have here our fixed size array. What is interesting in this case is that our flexible array member has exactly the same name as our fixed size array. Okay, so the second part, where is? Yeah, oh yeah, this is the interesting part. At runtime, the array that is being accessed is the flexible array, not the fixed size array. So again, the fixed size array is used merely as a placeholder, right, to allocate space in the structure so that we can iterate over our flexible array member. Okay, yeah, so at runtime, what happened is that, well, in the code at the bottom, main copy is trying to read data from the fixed size array, right? However, that is not possible anymore because we can no longer access that flexible array member. At the moment we changed the type of the conflicting object, we lose visibility into this array, which is the flexible array member, right? Okay, so now we are fixing a warning, but we are getting into trouble because the code wants to access the flexible array member. So how do we fix that issue? I mean, one solution, and the solution we are using is, we are using the container of helper. So, well, of course, you all know how this works, right? But as a reminder, okay, container of, what it does is, we need, I had conflict with how the parameters of container of are with the sequence that they have. I mean, I would have changed this. I would have implemented this as first pass the type of the structure from which you want the address from, and then pass the name of the member, and then pass the address of the member. But here, the container of, first we need to pass the address of the member, then we need to pass the type of the containing structure, and then we need to pass the name of the member, right? It's confusing. Okay, so what we do with container of is we retrieve the address of the flexible structure, and once we have the address of the flexible structure, we can access any member in the structure. In this case, we can access the flexible array member, right? That we have previously left out of the equation with the use of through group. So this is exactly how we are fixing this issue. We have container of. Here we have we have to add a new pointer, which in this case, of course, the type of the pointer is that of the type of the flexible structure. Then we pass, of course, we have the address of one of the members in the flexible structure. In this case, header would be that member. We pass, of course, the address of the flexible structure, and we pass the name. This header, this identifier, was created at the same time that we use through group. And well, at the end, once we have the address of the flexible structure, we can just dereference the flexible array member. And with that, we gain access to the flexible array member, and that's basically the trick behind this problem. And here is the complete code. Yeah, we have here, this is the composite structure, this is the conflicting object. We change the type. With this, we lose visibility into dies. However, with the use of container of, we now have access. This identifier is this. So thanks to this identifier is that we actually can access the flexible array member. It's a bit complex, but it's a general solution for these sorts of issues. I presented this a couple of times the last year at a Linux kernel conferences. And I got a comment from the maintainers that probably what we need to do is that we need to go and try to fix this case by case. And my answer to that is yes, if you can do that, please do it. However, what we are proposing here is a general solution, right? Because I ran into this situation when I was trying to fix one of these issues with a stru group. And in networking, there is this netdev socket. There is this netdev structure. It's like a 300-line structure. And I wanted to group all those 300 members with stru group. And of course, the maintainer was yelling at me. He didn't want this to happen to his code. So what he told me is that he was going to take a look at his code and try to refactor his code so that I don't have to use stru group in that code, right? And actually, they did it. They took them like a month to refactor the code. They were already in the process of refactoring a little bit of the networking code. And yeah, so at the end, they managed to place some very annoying flexible array member that was in the middle of multiple structures at the end of all those composite structures. And with that, they, we got rid of a lot of these warnings. And yeah, if you ask me, that's the best possible solution. But that is a lot of code. And probably in some scenarios, that is not possible because probably because of how certain protocol works, the code ended up looking like that. And there is not much that we can do about it. But this is the general solution. And this is something that I've been fixing a lot of code with this solution. And well, we have dozens of patches in mainline already. And well, again, this is how we just need to find a way to access the flexible array member, getting the address of the flexible structure. Okay, case number 4. Case number 4 is quite similar to case number 3. However, this is on stack. So here's an example. We have here, again, our flexible structure and our flexible array member. And at the bottom, we have our fixed size array. And the type of the fixed size array is exactly the same type as the flexible array member. So yeah, that's the compiler complains that here we have a flexible array member in the middle of this structure on stack, right? Okay, so this is kernel code. And this is an example of how I fix one of these issues, and actually how I am fixing all of those issues. This time we use a new helper macro, define Wflex. This macro was originally created to address those cases where we know at build time how large the flexible array member is going to be, so we don't have to allocate any heap space. So we can use some tricks and allocate this on stack. And this is an example how this is the conflicting code. Here is where the warning is triggered. And well, we just need to pass the type of the flexible structure. This is a new object. This is a pointer. Entry in this case is the flexible array member, and the last parameter, or well, the last argument that we pass to this macro is the number of elements that we want our flexible array member to contain, right? And well, here we have index 0 and index 1, and that is basically the solution for case number 4. We have declare flex, we have declare flex, and declare Wflex. Declare flex is used when the flexible structure is annotated with the counter by attribute, right? So what declare flex does is that now that we have a counter member, we can also at the same time initialize that counter member, right? And well, here are a few examples of some commits. you are curious, well, you can take a look and you can see how these issues are being fixed. Okay, so now let's talk a little bit about other issues. Oh, thank you, 5 minutes. Okay, let's talk quickly a little bit about other issues we have run into while addressing these problems, right? Here I have a piece of code. This is part of a patch that I implemented. If you notice here, I am using struGroup, and I am using struGroup in UAPI code, right? This is user space code. Okay, so I remember I wrote this patch to fix these issues, and then the maintainer of networking sent me this message. He basically, what he says is that he was trying to build some C++ libraries, and he was including this header while he was trying to build these libraries. And well, C++ complained about it, and the code didn't compile. So I basically broke user space with this patch. And this is the warning that C emits. Well, actually, it's an error. Basically, what it says is that C++ doesn't like to declare types inside anonymous unions. And this is exactly what we do with struGroup. We have a union, we have an anonymous structure, but we also declare a new type inside this anonymous union. So this is what GCC doesn't like. And this was a problem because, well, we broke user space, and at first I wanted to revert all those changes. They were few, but I wanted to revert them because, well, I was really freaking out. I was like, oh my God, I just broke user space, so I wanted to remove those and take my time to think about a general solution. But Cakes proposed a case-by-case fix, and well, he actually went ahead and sent a patch. When he sent a patch, we received this reply from this person. I think he works on networking code. But yeah, well, the thing is that this person came and said, well, you know, I have run into this problem before, so here is a fix for that, right? And we took a look at the fix, and yeah, it was a sensible fix. It was a general solution. And yeah, we said, yeah, please send it upstream. And then I clicked on the link, and this is what I found. This is part, of course, of the commit text, of the commit log. But what I want you to pay attention here is the date. He had a fix in 2022, and this networking maintainer complained about this issue in November, I guess, from last year, right? So we had mixed feelings about it. We were like, oh my God, I mean, you had this fix more than 2 years before someone reported this to us. So why didn't you send this upstream in the first place, right? And yeah, so the moral of the story is, this is the commit upstream. And the moral of the story is this. I mean, if you work downstream and you run into a problem and you have a fix for that, please send it upstream, because you never know when that problem is useful for the whole community, right? So yeah, that's the moral of the story. Okay, let me go quickly. What is next in Kernel Self-Protection Project? The counted by attribute is going to be extended to pointers now. That is amazing. So now we can link the counter member to a pointer, right? And through that, I'll add bounce check-ins at runtime on pointers. However, on pointers, we don't necessarily have to place the pointer at the end of the structure. I mean, it's a pointer. It can be anywhere. And well, this is under development. It's being implemented again by Xin Tao. And on the client side by Bill Wendling. I am including their names because they deserve recognition. They are not usually presented at conferences, but they do amazing work in the kernel community. And well, they are part of the Kernel Self-Protection Project. So that is coming. And with that, we can also, this is something that we don't currently have with the counted by attribute. In this case, the counter is in a different structure. This is not possible at this moment with counted by, but this is going to become possible once we extend counted by to pointers. Anyway, conclusions, well, a simple 3-step solution for the most complex case when it comes to addressing the issue of having having holes in the middle of structures with this flexible array member in the middle. So we can use the struct group family of helpers. Then we change the type of the conflicting object, and we use container of to access the flexible array member that was left out of the equation when we used a struct group. And well, in the case of this problem, some stack, we can use the declare flex and declare raw flex macros. And well, we have a clear strategy on how to fix these thousands of warnings in the kernel. I have sent dozens of patches. They are already in mainline. With this, I managed to go from 650 to a little bit more than 300 of these unique issues in the kernel. So I still have like a little bit a little bit more than 300 to address. And well, basically 30%, like 20,000 of these warnings have been fixed with these strategies. And well, again, please upstream first. And with that, thank you.
All right. Well done. Thank you very much, Gustavo. Unfortunately, we do not have time for questions, but I'm sure I'm happy to take questions out in the foyer.
Yes,
and
absolutely.
Got a small token of appreciation from the conference organizers.
Oh, thanks so much.
So
thank you.
Thank you once again.
Thank you.